You know, every time you send a file, stream a movie, or just browse a website, you're using one of the most incredible machines ever built. The thing is, most of how it works is completely hidden from us. So in this explainer, we're going to pull back the curtain on that invisible engine that powers our entire digital world.
I mean, really think about it. In just that one single second, this whole cascade of events kicks off, sending your data on a wild journey across cities, countries, maybe even oceans. It's not magic, not at all. It's just a brilliant system of rules and infrastructure. So let's follow that journey and see what's really going on.
All right, so how does any of this work? Well, for the internet to function at all, every single device connected to it needs to speak the same language. And this shared language is built on two things: a set of rules, which we call protocols, and a basic structure that organizes the entire conversation. Let's break that down.
So what is a protocol really? It's basically a handshake agreement. It defines exactly how data should be formatted, how it's addressed, transmitted, and received. Without these rules, a message sent from an iPhone would be complete gibberish to a Windows server. You can think of it as the universal translator for the digital age, making sure everyone is on the same page. Okay, so who's actually doing the talking here? Well, most of the time, it's what we call a client-server relationship. Your device, your phone, your laptop, whatever you're using, that's the client. It's the one making a request, like, hey, show me this web page. And somewhere out there in the world, a powerful, always-on computer called a server is just sitting there, listening, ready to serve up exactly what you asked for.
Let's make this real with something we all do every day: sending an email. That simple act is actually a perfect way to see these protocols working together in this beautiful, totally invisible dance.
The second you hit send, your email client uses something called the Simple Mail Transfer Protocol, or SMTP. You can think of SMTP as the digital postman. Its only job is to push your email from your mail server across the internet to your friend's mail server. It's a one-way street, always moving that mail forward until it's delivered to the right place.
But of course, sending is only half the story. How do you actually get your mail? Well, there are two main ways. The old way used POP3, which is a lot like a physical P.O. box. It downloads your mail to one device and then usually deletes it from the server. But today, almost all of us use IMAP, and IMAP is more like cloud storage for your mail. The email always stays on the server, which is why it's perfectly synced across your phone, your tablet, and your computer.
Okay, but wait a second. That brings up a huge question, right? We wrote an email to a person's name at a domain, not some long string of numbers. So how in the world did our server know the exact numerical address of that specific mail server out of the billions of devices on the internet?
Well, the answer is a system that might just be the single most critical piece of the internet's infrastructure, and it's one most people have never even heard of. It's called the Domain Name System, or DNS. Put simply, it's the internet's universal address book, and without it, the internet as we know it would be completely unusable.
Here's the key thing to understand. While we humans think in names, like Google.com, computers only think in numbers, these things called IP addresses. DNS is the massive worldwide database that handles this translation. When you type in a web address, DNS is what turns that easy-to-remember name into the specific IP address the computer actually needs to find the right server.
And it does all this in just milliseconds to this really clever hierarchical search. Your computer basically asks a series of servers, and each one gets you a little closer to the right address. It starts local, then if it doesn't know, it goes to a root server, then a TLD server for the .com or .org part, and then finally to the domain's authoritative server that has the exact IP address. It's this amazing chain of command that finds the right computer in the blink of an eye.
And get this, DNS isn't just for websites. It has different types of records for different jobs. Now, let's go back to our email example for a second. The MX, or Mail Exchange Record, is the one that solves our big mystery. It's the record that tells your mail server exactly which server to send that email to for that specific domain. It's the secret sauce that makes the whole email system work. So we've seen how the internet handles something relatively small, like an email. But what happens when we scale that up? I mean, way up. What about streaming a 4K movie? The architecture that was built for text had to seriously evolve to handle the massive demands of video, without that constant, frustrating buffering we all hate.
And the scale of this challenge is just staggering. I mean, look at this. Just two companies, Netflix and YouTube, are responsible for over a quarter of all downstream internet traffic. That is an unbelievable amount of data. Delivering all of that smoothly requires some very, very clever technology.
So, part one of the solution is this amazing technique called Dash. See, the video you're watching isn't one giant file. It's broken up into these tiny, few-second chunks. Your video player is constantly measuring your internet speed and intelligently asking for the next chunk at the highest possible quality your connection can handle at that very moment. That's why your video might start a little blurry and then suddenly snap into crystal clear HD. It's adapting in real time.
The other key piece of the puzzle is something called a content distribution network, or CDN. Think of it like a franchise. Instead of having one giant Netflix warehouse in California, they have smaller warehouses all over the world. They place copies of popular shows and movies on these local servers, so when you press play, you're not streaming from halfway across the globe, you're getting it from a server that might just be a few miles away. This cuts down the distance, reduces lag, and makes the whole experience way smoother.
Okay, so let's bring all of this home. We've looked at a few different pieces of the puzzle, but the real magic is how they all work together to create this totally seamless experience for us.
Think about it. From the simple push of an email using SMTP, to the brilliant lookup system of DNS that finds a destination, all the way to that complex dance between Dash and CDNs that lets you watch a movie instantly, we rely on this incredible layered system of protocols. It really is the invisible engine that's constantly running in the background, adapting, and delivering our digital lives one tiny packet of data at a time.
But here's a final thought for you. This engine we've been talking about, it was designed in an era of text and images. As we move into a future of immersive virtual reality, real-time AI, and literally 1 trillion connected devices, what new protocols, what new architecture are we going to need to invent? The next invisible engine of the internet is being designed right now.